Hello and welcome back to Chopstick Maths. In this video, we are going to solve a sum from exercise 1, question 5, sub question 2. Prove that 1 plus root 3i the whole raised to n plus 1 minus root 3i the whole raised to n equals to 2 raised to n plus 1 cos n pi by 3. Now, the left hand side has two complex numbers 1 plus root 3i the whole raised to n and 1 minus root 3i the whole raised to n. We need to expand this and then we need to add the two complex numbers. Now to expand this 1 plus root 3i the whole raised to n and 1 minus root 3i the whole raised to n, we will need De Moivre's theorem. And for that we will need to convert these two complex numbers 1 plus root 3i and 1 minus root 3i into its polar form. So let us do it step by step. So consider the number 1 plus root 3i. Let us convert this in the polar form. So let Z1 be 1 plus root 3i. So let us represent this complex number on the Argand's diagram. So let P be the location of the complex number 1 plus root 3i. Now in this complex number 1 plus root 3i, x and y both are positive, hence it lies in the first quadrant. Now x is 1 and y is root 3. So both the numbers are x and y, both are positive. OP is the magnitude of the complex number and theta is the argument. So let us find the magnitude first. So magnitude of Z1 is under root of 1 square plus root 3 square, which would be under root of 1 plus 3, which is under root of 4. So magnitude of Z1 is 2. Now the argument. Now theta is the argument and theta is equal to tan inverse y by x. X is 1, y is root 3. So theta is tan inverse root 3 by 1. Now since it's in quadrant 1, the complex number is in quadrant 1, theta is positive. So theta is equal to tan inverse root 3 by 1, which is tan inverse root 3. Therefore theta is 60 degrees or pi by 3 radian. Now let us write this number in the polar form as we have calculated the resultant and the argument. So 1 plus root 3i is 2 into cos pi by 3 plus I sin pi by 3. Now let us raise both the sides to the nth power. 1 plus root 3i the whole raised to n is equal to 2 cos pi by 3 plus I sin pi by 3 the whole raised to n. Now after having done this, we'll have to use the law of indices. So 1 plus root 3i the whole raised to n is 2 raised to n into cos pi by 3 plus I sin pi by 3 the whole raised to n. This is as per the law of indices. Therefore, 1 plus root 3i the whole raised to n is 2 raised to n into cos pi by 3 plus I sin pi by 3 the whole raised to n. So now we can apply the De Moivre's theorem as we have the number in the CIS form. So 1 plus root 3i the whole raised to n is 2 raised to n cos n pi by 3 plus I sin n pi by 3. So ultimately we can write this as 1 plus root I the whole raised to n is 2 raised to n cos n pi by 3 plus I sin n pi by 3, and we can call this 1. So we have now written this first complex number in its polar form. So now let us write the second number. Now let us write the second complex number 1 minus root 3i in the polar form. So let Z2 be equal to 1 minus root 3i. Expressing Z2 in the polar form, so let us first represent the number, complex number 1 minus root 3i on the Argand's diagram. So let P be the location of the complex number 1 minus root 3i. Now here x is positive and y is negative, so the complex number is in quadrant 4. X is 1 and y is minus root 3. OP is the magnitude of the complex number 1 minus root 3i and alpha is the argument. So the magnitude Z2 is equal to under root 1 square plus minus root 3 square. That is equal to under root of 1 plus 3, which is equal to under root of 4. So the magnitude of Z2 is 2. Now let us calculate the argument. The argument alpha is tan inverse y by x, which is equal to tan inverse root 3 by 1. Now I have put this value of y and x both as positive because y is negative and x is positive, but here I have put y positive and x, of course x is positive here. So tan inverse root 3, okay, that is equal to alpha. So alpha is equal to pi by 3 radian. But however, we are getting angle positive because here we have put both the values positive. But however, angle is moving in the clockwise direction. So the angle is negative. So we can write theta is equal to minus alpha. So theta is equal to minus pi by 3. Now we have calculated the magnitude, which is 2, and the argument, which is minus pi by 3. So let us write the number 1 minus root 3i in the polar form. So 1 minus root 3i is 2 cos minus pi by 3 plus I sine minus pi by 3. That is equal to 2 cos pi by 3 minus I sine pi by 3. Because cos of minus theta is cos theta and sine of minus theta is minus sine theta. So that is how the plus sign changed to minus as per this property of sine of minus theta is equal to minus sine theta. Now let us raise both the sides to the power n or to the nth power. So 1 minus root 3i the whole raised to n is 2 cos pi by 3 minus I sine pi by 3 the whole raised to n. So 1 minus root 3i the whole raised to n is 2 raised to n into cos pi by 3 minus I sine pi by 3 the whole raised to n as per the law of indices. Now we have written this complex number 1 minus root 3i in the polar form, that is the CIS. So we can now use De Moivre's theorem. Therefore 1 minus root 3i the whole raised to n is 2 raised to n cos n pi by 3 minus I sine n pi by 3. Let us call this 2. So now we have to add these two numbers, that is the left hand side, 1 plus root 3i the whole raised to n plus 1 minus root 3i the whole raised to n. That is equal to 2 raised to n cos n pi by 3 plus I sine n pi by 3 plus 2 raised to n cos n pi by 3 minus I sine n pi by 3. Now we can take out the 2 raised to n common here. So 2 raised to n common outside into bracket cos n pi by 3 plus I sine n pi by 3 plus cos n pi by 3 minus I sine n pi by 3. This plus I sine n pi by 3 and minus I sine n pi by 3 cancel out each other. So 1 plus root 3i the whole raised to n plus 1 minus root 3i the whole raised to n is equal to 2 raised to n cos n pi by 3 plus cos n pi by 3. That will be equal to 2 cos n pi by 3. So 1 plus root 3i the whole raised to n plus 1 minus root 3i the whole raised to n is equal to 2 raised to n into 2 cos n pi by 3. Therefore, by the law of indices, 2 raised to n into 2 raised to 1 is 2 raised to n plus 1. Therefore, 1 plus root I the whole raised to n plus 1 minus root 3i, 1 plus root 3i the whole raised to n plus 1 minus root 3i the whole raised to n is equal to 2 raised to n plus 1 into cos n pi by 3, which is equal to the right hand side. Hence, proved. So, thank you very much for watching.